Hello everyone. So I'm going to introduce my research study in 4 sections: research goal, research questions, methodology, and implications. First, my research goal is to understand how computational thinking manifests when elementary students engage in individual programming activities. And my motivations behind this study is that I had a lot of experience working with elementary students in their computing class, and I can see they have great potentials in learning computational thinking concepts and in solving programming problems. But we know that CT is still a young topic, and its definition is still evolving, and the methods to understand CT in elementary class are still developing. So I'm very excited to see whether my study can help provide useful insights to help people understand CT in elementary education. So framed by this research goal, I have 2 questions. First, what elementary students attend to when they engage in individual programming activities? Number 2, what strategies they use in solving programming problems? And to answer the questions, I'm going to employ the sequential explanatory mixed method by drawing information from 2 sources of data. First, quantitatively, I'm going to employ the eye tracking technology by collecting eye gaze data from students. Specifically, I'm looking for fixation counts, fixation durations, and fixation distributions and scan path. And by using the eye tracking data, I can get a general picture of where and what students are looking at when they program. However, the eye tracking data alone cannot give information of how and why. So to complement eye tracking data and to provide additional explanations, I'm going to perform a qualitative data collection by using retrospective think aloud. So during the think aloud, students will be prompted to recall their thought process and to report the problem-solving strategies they used and to reflect on some general questions about the programming process. So by combining eye tracking data with the think aloud data, the study is going to provide a more comprehensive picture about the students' thought process and their problem-solving strategies during the programming activities. And finally, this study is expected to provide implications for computer science researchers, practitioners, and technology designers, specifically regarding the methodological improvement and some pedagogical insights and suggestions for improving the platform design. Thank you.